In this video, let's study closed pair problems. Given a connection of points P consisting of P1, P2 through Pn in 2 dimensions, we would like to find the pair of points Pi, Pj that minimize the Euclidean distance between them. For example, here, let's assume we have n green points. We want to find through these n green points, we want to find the smallest, the closed pair. And if we have n points, and we could have n choose 2 pairs, and through this n choose 2 pairs, we found a minimum one. And such that we can see here the runtime by using this brute force method, the runtime is O(n) squared. And also here, let's think about if there's no 2 points have the same x coordinates, no 2 points have the same y coordinates, right? Let me see if we have some is exactly same coordinates, x or y is in the same coordinates, this problem reduced to be points, n points in the 1 dimensions. And such that sorted number work from left to right to find a minimum gap, right? Because you sort that, in that case, n log n. Now the question is if there is 2 dimensions and with no 2 points in the same x coordinate, no 2 points having the same y coordinates. Can we have a better solution better than O(n) squared? Can we have n log n? Which usually divide and conquer give us better solution in most cases. And for example, if we sort the whole points by x coordinates, and in that case, once you sort by x coordinates, it will be easy to find the median based on x. And we draw the line, show this x median, and we use this median point, divide the whole sequence, whole points into the left points and right points. And the left points always has x coordinates smaller than this x median. And the right area, all the points in the right side and corresponding to the x coordinates greater than the median coordinate. And we use the same procedure and work on the points in the left side, and we use the same procedure, work on the points in the right side. And it's such that in each side, we suppose we get the smallest pairs, right? The shortest pairs, the closed pairs. The theta 1, we got the closed pairs in the left side. Theta 2, we got the closed pairs in the right side. And we choose smaller one. Now the question is there any point in L and a point in R whose distance is smaller than what we have this is theta, the smaller one from theta 1, theta 2. For example, if possible, this could be the closed one, right? Because this is what you find the theta equal to the theta 1. And this part is what we have theta 2. And we want to check if there's any pair which even have smaller than theta 1, and which it is 1 point in the left side, 1 point in the right side, right? If both in the one side, in that case, definitely it will belong to, the what you searched in the left side or right side. If the answer is no, then we are done. If the answer is yes, then the closed such pair forms the closed pair for the entire connection, right? That makes sense. So then the question is, can we find the closed pair, which cross the x median, and such that the solution to find the shortest one, even shorter than theta, And that procedure do not need n square, right? If it is linear, that is fine. We see that is true. The reason it is, since we want to find the pairs cross its x median, and the distance between the 2 points should be smaller than theta, right? This is what we want to find. In such case, we draw 2 lines along these x coordinates and these black lines, right? We see that the points we want to find the pairs, right? One is from the left, one is from the right. We see the point in the left side for that pair will level beyond the distance theta compared to this x median. The same thing here, and the point we would like to find in the right side, which is belong to the pair shortest pair, will level beyond the black line, beyond this the x median plus theta, right? This is x median plus theta. And this is x median minus theta, right? Okay. And such that we just need to consider this narrow band. And we see even for this narrow band, and actually we can draw a rectangle. If this is the theta, and here we see this is the theta, right? Because the pairs, the shortest pairs will never be longer than what we have the theta here, right? If it's longer than this one in the y-axis, then they will have a problem. And so this reason, we say, okay, we draw 2 lines, we pick up the points from here, we sort it by y coordinates, and then we check the closed points, and usually not more than 30 adjacent points, right? And then you can scan in each points in this short band, the narrow band, and we see since you check for 30 adjacent points, and such that at random it is big O(n). And then this is we combine the left side and right side based on we check there's any shortest pair and which include the points. One came from the left side, one came from the right side. And such that this question reduced to give the points, give endpoints. First, you divide these endpoints based on x median. And then you use the closed pairs method, check the left side, and use the closed pair method, check the right side. And then we use the linear random, linear logarithm to combine the left side and the right side, check the points across the x median. And based on what we analyze in the merge sort and quick sort, we see this procedure need to have O(n) log n, right? The reason it's the same Tn equal to 2Tn because it's median, right? So you can crossly to be n divided by 2 plus O(n). And based on this one, we can say use the master method. You have O log n. Right? Okay, so this is the closed pair problem.